the determination of nuclear products. The nuclear reactions between the deuterium nuclei in vacuum are the following. The determination of tritium and the neutrons did not pose particular difficulties. Tritium was determined with a liquid scintillator in heavy water produced by the catalyzed recombination of deuterium and oxygen in the gaseous phase, leaving each cell. No possibility of environmental contamination. Neutron was determined with a high-efficiency neutron counter built at the Jomar Corporation of Los Alamos, on project by the nuclear physicists' colleagues. The reliability of the counts was based on the discrimination between a neutron of cosmic nature and from any environmental electrical interactions. The determination of helium-4 unfortunately posed more difficulties and required more attention due to the quantitative ratio helium-4 deuterium is expected very small. The concentration of helium-4 in air is 5.24 part per million. Possible environmental contamination. Mass spectrometric determination of helium-4 in presence of deuterium. The spectrum in the figure represents the separation of helium and deuterium in a one-to-one mixture. The axis of mass is purely arbitrary, and this point of the separation between the two peaks is located in the valley at 4.0111. Since the mass difference between helium-4 and deuterium is only 0.0256 units, in the presence of large quantities of deuterium compared to helium-4, the separation of respective peaks would be impossible. It's necessary to remove most of the deuterium by means of a getter and an activated carbon trap at the temperature of liquid nitrogen. With this procedure, the measurement of traces of helium-4 becomes possible and sufficiently accurate. Neon as a marker of helium-4 from air contamination. The experimental system was designed and built to safely determine the possible production of helium-4 associated with excess heat. The basic requirement was to avoid any air contamination in the gaseous mixture generated by the electrolysis. The helium-4 content in air is 5.24 ppm. In case of detection of helium-4, especially if at a concentration comparable to those of helium-4 in air, it was necessary to identify the source. The concentration of neon in air is 18 ppm. Presence of neon together with helium-4 implies contamination. High-resolution mass spectrometry identifies a mass of neon-20 in an area of a spectrum where other species appear clustered around this mass, which make their determination difficult. It was then decided to follow the spectrum around mass 10. It has neon-20 2+, where there is no significant interference. The high-resolution mass spectrometry measurements were performed in multiple ion detection mode, so ionic currents versus time. They were helium-4, the valley between helium-4 and deuterium, and deuterium and neon 2+. The control of the ion current corresponding to mass 4.0111 is a key parameter to ascertain the real separation between the peaks of helium and deuterium. The last experiment, the overall scheme. To simplify the diagram, the circuit for a single cell is shown. The experiment was with 4 cells connected in parallel for the supplies of nitrogen, heavy water, and the thermostated water. The series connection only for electrolysis current. Each cell had its own analog data acquisition and the digital channels for the event management. The gaseous mixture leaving each cell was connected to the respective catalytic recombiner. The function of a catalytic recombiner is to make offline determination of tritium in the recombined heavy water and the measurement of electrolysis efficiency by the volume of heavy water recombined and amount of electrolysis charge at the time t. The flow of the cell being measured was automatically directed to the deuterium abatement system unique for all the cells.